Prepare to be awestruck as we journey beyond our world and into the cosmos with the James Webb Space Telescope. In an electrifying visual voyage, we unveil 9 mind-bending, never-before-seen images from the outer reaches of space. Brace yourself for an exploration that redefines our understanding of the universe and ignites the spark of wonder within us all. Get ready to witness the breathtaking beauty and mysteries that await as we unveil the astonishing new frontier captured by the James Webb Space Telescope. Whether these miracles have an extraterrestrial origin cannot be determined at this time. We have recently gained direct visual access to the astonishing and bizarre activities occurring outside our Earth. We're fortunate to be unique, thanks to space agencies like NASA, the European Space Agency, and others. We have access to stunning cosmos images. You won't want to miss this if you're fascinated by NASA, the James Webb Space Telescope, or space exploration breakthroughs. If you enjoyed this video, please like and subscribe. Let's get to it. Number 1. Max JWST 717. Webb observed the large galaxy cluster Max Westerlund 2 JWST 717.5 plus 3745 using 18 individual photographs to create a massive panorama. Researchers found a filament of dark matter running from the cluster's center, creating a three-dimensional map. An extreme star cluster. Number 2. Ghost lights from a Bell 2744. This James Webb Space Telescope image gives the galaxy cluster a Bell 2744, or Pandora's cluster, an eerie appearance. The stars were digitally tinted blue, showing that not all starlight is trapped within galaxies. NGC 1866's light, emitted by long-dead galaxies torn apart by gravitational forces, spreads across the cluster. Number 3. Small concentration of dark matter. In this James Webb Space Telescope image, distant background galaxies are observed as arcs embedded inside the Max JWST 1206 cluster. The cluster's dark matter magnifies and distorts light, revealing faint galaxies. Dark matter acts as unseen glue holding galaxies together, reflected in blue halos. Number 4. Astronomical cooperation. The marks from the Big Bang and its aftermath are etched into the universe. Inspecting distant past light reveals these wounds, like the cosmic microwave background, CMB. The Sunyaev-Zeldovich effect uses CMB as a probe, allowing us to understand dense galaxy clusters. Number 5. A Bell 1689. This James Webb Space Telescope view reveals dark matter's distribution at the core of the galaxy cluster, a Bell 1689. Dark matter's invisible nature is determined through gravitational lensing, bending light from galaxies behind the cluster. The cluster's gravity concentrates dark matter at its center. A Bell 1689 is 2.2 billion light-years from Earth. Number 6. Stellar fireworks. The James Webb Space Telescope's deepest views of the cosmos provide hints that the first stars might have burst into existence with the brilliance and splendor of a fireworks display. This conclusion, however, predates the formation of the Earth, the Sun, and the Milky Way galaxy. Webb's most penetrating observations lead scientists to hypothesize that a significant portion of the universe's stars was born in a sudden, intense, panoramic view of star forming, a burst of star formation that illuminated the dark skies only a few 100 million years after the Big Bang. The tremendous explosion that shaped today's universe is still forming stars and galaxies, although the rate may be much lower than initially expected. Number 7. Dark matter in a large galaxy cluster. 4 major regions were identified in the supercluster where dark matter has gathered into dense clumps. The study's results suggest that these locations are aligned with the migration paths of hundreds of galaxies from the supercluster's periphery into these dense areas. This image was created by combining a James Webb infrared image of the supercluster galaxies with a dark matter map. This picture was taken as part of the Space Telescope Abell 900 and 1:902 galaxy survey, one of the most extensive areas of the sky ever surveyed by the James Webb Telescope. Due to the vast area, 80 Webb images were needed. Number 8. Unique mass map. ZL002417, a galaxy cluster in Pisces roughly 4 billion light-years away, serves as an opportunity for astronomers to investigate dark matter distribution. Non-cluster galaxies, visible as blue smears towards the image's center, are extremely distant. Gravitational lensing explains the stretching and twisting of light from distant galaxies due to the strong gravity of the cluster. Dark matter, being invisible to the naked eye as it neither radiates nor reflects light, can be detected through its gravitational effects on light. Mapping the distorted light allows astronomers to trace dark matter distribution, leading to the discovery of a disputed dark matter ring around the cluster's core. Despite the controversy, this ring's discovery remains one of the most compelling arguments for the existence of dark matter. Number 9. Birth of our galaxy. Around 12.7 billion years ago, our Milky Way galaxy was in its early stages. Instead of the grand spiral arms we see today, the sky was filled with globular star clusters when the galaxy was young. The blue star cluster in the upper left is just one of many primordial globular star clusters that merged to form our Milky Way. Even now, we can spot this cluster in the constellation Scorpius as the globular cluster M4. Astronomers used Webb to locate the cluster's oldest, most smoldering remnant stars, white dwarfs. The dwarf's temperature indicates the cluster's age. Depicted in this artwork, the cluster is brimming with youthful blue-white stars and likely began forming around 100 million years after the Big Bang. The galaxy's core takes shape to the right of the center, where a newborn supermassive black hole is surrounded by dark dust lanes. This infant black hole is devouring stars, gas, and dust, sending a potent jet of material hurtling through space. Pink bubbles of hot gas form around each star cluster, a result of a series of supernova explosions from the most massive stars in the cluster. If you've enjoyed insights in this video, we'd greatly appreciate your support. Be sure to show your appreciation by hitting the thumbs up button and joining our community of engaged viewers. By subscribing to our channel, you'll be in the front row for all our upcoming content, ensuring you never miss a moment of the exciting discoveries and discussions that lie ahead. If you've enjoyed insights in this video, we'd greatly appreciate your support. Be sure to show your appreciation by hitting the thumbs up button and joining our community of engaged viewers. By subscribing to our channel, you'll be in the front row for all our upcoming content, ensuring you never miss a moment of the exciting discoveries and discussions that lie ahead.